Okay, integration by substitution. So more often than not, you'll be given the U substitution. I'm going to do this question twice. I'll show you the alternate method later on. But let's look at this first. Okay, U equals 2x plus 5. Cool. So, let's make that nice and simple. U is 2x plus 5. Du over dx is 2. So, I can also say U minus 5 over 2 equals x. So let's rewrite this question. Okay. So x here is U minus 5 over 2. I'm going to write that as a half U minus 5 over 2. And we're going to multiply that by the square root of U dx. Well, what we can say here is du equals 2 times dx. So du over 2 equals dx. So I'll multiply that by du over 2. Okay. So we want to clean this up a bit. So let's have a look at it. Let me see. Okay. I'm going to do the integral. I'm going to do a half times U minus 5 multiplied by the square root of U times a half times du. So we can see how the halves are going to group up to be a quarter, and we can pull that outside. So we've got a quarter integral. We've now got the square root of U times U minus 5 du. That's a lot cleaner now. Let's get these into fractional form. So U to the half times U, that's going to give us 3 over 2 or 1.5 minus 5U to the 0.5 du. And now we're going to integrate it. So we're going to get the quarter on the outside still. U 1.5, we're going to plus 1 and then divide by it. So we're going to get 2/5 U 2.5 minus, we're doing 5 divided by 1.5. So 5 divided by 1.5 is 5 times 2 over 3. Lovely. So 10/3. U to the 1.5. There we are. We'll have the plus C, don't forget that. And now we just want to substitute U back in. So what was the U? U was 2x plus 5. Lovely. So the final answer is, we'll get the quarter. And we're going to do... Actually, no, I can multiply the quarter out, can't I? Yeah, I can. Let's do 2 over 20, which is 1/10. U 2.5 minus 10 over 12. 5/6, yep. U 1.5, and the plus C will just stay there. So final answer, the U is, got it again, 2x plus 5, lovely. So we're doing 2x plus 5, 2.5 all over 10, minus 5 lots of 2x plus 5, 1.5, all over 6, plus C, and we're done there. Cool. So that's the first one done there. Lovely. I will move on. Okay. Here, we're just looking at, again, you're going to get the U substitution, but let's look at some sensible solutions here. Sensible. This is only really useful for like MAT and step stuff in case it ever comes up. So I'll make U whatever is under my square root. That'll help us there. Here, I'm going to make U dx squared, because I can use, I can get root of U and U here. Here, I'm going to do U is 1 plus x. And here, we're going to do U equals the whole power. Lovely. But yeah, that's really just for like step stuff, so nothing really to worry about there. Okay, let's have a look at this one here. Right, we're given a substitution. So I've got U equals sine x plus 1, and I want to integrate cos x times sine x, multiplied by 1 plus sine x cubed dx. Okay, let's have a look at it. Right. U is sine x plus 1 du over dx, or sine x becomes cos x. That's it. Great. So du is cos x times dx. Great. Well, I can see cos x dx is here. Okay, so that's going to become du. That's going to be helpful. I'm going to read the notes. Yeah, fine. Okay, so we're going to do the integral. Sine x, or sine x is u minus 1. We can see that here. And 1 plus sine x is u. We've got that in the question. So that's u cubed, and cos x dx becomes our du. Lovely. Now this is a really simple question. The integral u to the 4 minus u cubed du. And that equals u to the 4, we add the power u to the 5 divided by the power 1/5 u to the 5 minus a quarter u to the 4 plus c. Don't forget what the u originally was. So the final answer is 1/5. U is sine x plus 1. Sine x plus 1 to the 5 minus a quarter sine x plus 1 to the 4 plus c, and we're done. Easy. Okay. Right, this is the same question from before, but sometimes we can do stuff alternate ways. So we're now going to let this square root be u squared. We're going to show an alternate method here. We're going to get the same answer, but it's good to know alternate methods. Okay, so we're going to do implicit, I can't say the word, differentiation. I can never say it. Fine. So u squared is 2x plus 5. Du over dx, we're going to get 2u du over dx equals 2. So 2u times du equals 2 dx divided by 2. U times du equals dx. Lovely. Alright, so we're going to rewrite the question now. Let's have a look. And also, by the way, u squared minus 5 over 2 equals x. So the integral, x becomes u squared minus 5 over 2. We're going to multiply it by this, which is the square root of that is u. So we're going to get that there. So we're going to times that by u. And then dx is u times that. So times u again, du. Okay. I'm assuming now, make this a bit cleaner. So we're going to get u squared minus 5. I'm going to pull out, I'm going to pull the half out. U squared minus 5 times u squared du. So I'm going to get half u to the 4 minus 5u squared du. Great, let's get the half on the outside. We're going to get 1/5 u to the 5 minus 5 over 3u cubed. Lovely, let's times it by a half. So 1/10 u to the 5 minus 5 over 6 u to the 3. Don't forget the plus c. And then u was the square root. Yeah, it's 2 to the x. Okay, let's just fix this. U is 2 to the x to the 0.5. That's fine. So we're going to get 1/10 2x. Oh, I forgot it. Plus 5. And what I'm doing is I'm doing 0.5 to the power of 5. So it's going to be 2.5 minus 5 over 6. 2x plus 5. 0.5 to the power of 3. 1.5 plus c. And we're done. And I think if I copy and paste that, alternate method, you can pause it here. Go back to the earlier question. Is it the same? It is exactly the same. Lovely, they all match up. Great. Fantastic. Done. Great. Okay, right, here's a test to understand the question. So let me zoom in. Hit pause now on the video and give it a go. I'm not going to give the answer. I'm not going to talk through it for the sake of time, but I'll write the answer here. Okay, there's the answer. Maybe I will. I'll come back to it. Right. Let me just carry on with these models for now. Nah, let me go back and do it. That is me, for anybody watching this. Because I'm making this for somebody and they will get the answer. But if anyone wants to watch this, I'll stop talking. Right. U equals 1 plus cos x. Okay. Are we given... Oh, no, we are given substitution. I've just read it. Right. Okay. Du over dx equals minus sine of x. So, let's divide it by that. Minus 1 over sine x du equals dx. Great. And we've got, we've also got u minus 1 equals cos x in the question there. Lovely. So let's rewrite this integral. 2 sine 2x. And we're given the answer. We're just trying to find what the k is. Right. 1 plus cos x dx. Key. Dx is here. I'm going to rewrite it as that. U is here. Lovely. What else am I doing? Let's see. Oh, sine of 2x is the double angle formula. So let's have a look at this. So I'm going to do 2 lots of 2 sine x cos x all over, I'll put the u in now, dx becomes, so times minus 1 over sine x du. Great. Okay, let's clean this up. Sine x cancels out there. Okay, and we've got 2 times 2 is 4. 4 times that. Okay, great. I can pull out the minus 4. And I'm left with cos x over u du. Great. Cos x is u minus 1. I can see that here. So it equals minus 4 u minus 1 over u du. Okay, lovely. I'll keep the minus 4 there. I'm going to rewrite that as u over u minus 1 over u du. So I'm going to have a space here, minus 4, 1 minus 1 over u du. Fantastic. So this equals minus 4, 1 becomes u, minus 1 over u becomes minus natural log over u, plus c. I'm going to go on to the next page now. So we're left with, we can substitute back in now, I guess. Minus 4. U in our original question was cos x plus 1. Fantastic. Cos x plus 1. Minus natural log cos x plus 1 plus c. And that's it. Fantastic. Let's look at the original thing. I can expand it out then. That's fine. Yeah. Great. I think we've done it. So we've got minus 4 cos x minus 4 plus 4 natural log cos x plus 1 plus, I guess, minus 4c, which is c. Fantastic. Let me just copy and paste that. Let's go back to the original question. And we are done. What do we have here? Cool, we've got the minus 4 cos x here. The plus k, I guess, is minus 4 plus c. Fine. 4 natural log cos x. Yeah, we got that all here. Great, so the k is 4. Fantastic. Yeah, the k is minus 4 plus c. Minus 4 plus c. Yeah, fantastic. Happy with that. K is a constant. Yeah, great. Cool. There's the answer there. Right. Lovely. Okay, let's just get this finished now. Let's look at a definite integral. So we've got the following. And I've got test understanding question there. Great. Okay, let's do u equals 1 plus sine x. So du over dx is cos x. So du equals cos x times dx. Great. Okay, so now I can rewrite this as, and what we got? We got u minus 1 equals sine x. Great. So the cos x dx becomes du. And we've got the square root of u. Easy. So we've got u to the half. That's the question here. So that's square rooted there. Okay, so now what we want to look at, when x equals 0, u equals 1 plus sine of 0, which is 1. So the lower bound becomes 1 when we're dealing with u. When x is pi over 2, u equals 1 plus sine pi over 2, and that's going to equal 2, 1 plus 1. So there we are. Those are my limits now. And this becomes a very easy question. 2 and 1, and we're going to do u half plus 1 is 3 over 2, divided by 3 over 2, which is 2/3. So we're going to get 2/3. And we're going to do upper limit of 2 to the 1.5. Take away the lower limit of 2/3 times, well, 1, isn't it? 1 to the power 1.5. Great. And we're going to get, so 2/3, 2 times 1.5 is 2 times root 2. So that is essentially 4 root 2 over 3. Take away 2/3. Final answer is 4 root 2, take away 2 all over 3. Lovely. Or you can take out a factor of 2 and you get 2 root 2, take away 1. Fantastic. So there we are. Change your x limits in terms of u, plug them in. Happy days. And here's a test to understand the question. So you can pause the video here. This video is dragging on, so give it a go. And it's just showing you the areas that, so you're given the answer. Can you get there yourself? Yeah, give it a go. And I'm going to call, I finished the video. I'll do it really quick. Let's have a look. Okay, u equals x squared plus 2. du over dx is 2x. So du equals 2x times dx. Great. What do we know? Okay, now we got lower limit of 2, upper limit of 4. All right, let's look at the question here. Sorry. Okay, I see. Right, so we're doing lower limit of 0, upper limit of root 2. We're doing x squared. That's cute. I think that's a typo in the question because, is it a typo? I think it is, because I'm working out, it's got something different. I think that's a typo because I've got a different thing in my working out from the slides. X squared plus 2. No, it's not. It's not a typo. Ignore me. is pull out a factor of x there, dx. Okay. Clever question. Right, 2x. Where is this coming from? Well, let's have a look at it. So we've got, that becomes u. So what is x squared times x? Okay. Dx times. So what this means is half du equals x times dx. So that x times dx becomes half. I can pull the half on the outside. Du. So where does this x squared come from? Oh yeah, x squared is u minus 2. Clever. That is clever. That got me there. Great. And now we can say when x is 0, u is 2 here. When x is root 2, u is 4. Clever question. Right, so now, yeah, we've done it. Bound and Lewis is proven that. Oh, that was tricky. Okay, cool. I'll call it there.